In the last segment, we discussed DevOps, but half of the course title is focused on infrastructure. So what do we mean by this term, infrastructure? Well, from an IT perspective, infrastructure represents all of the different compute, storage, networking, and software components that are required to deliver some sort of service. And we're going to be spending a meaningful time in this class looking at different infrastructure components and understanding how to architect them to deliver reliable services to our stakeholders and our customers. But before I really dive into modern infrastructure, I want to take a step back and look at traditional IT infrastructure. Now, in a traditional IT organization, as engineers, we considered ourselves to be artisans. We were handcrafting our infrastructure. We were building servers and networks and installing software by hand. And it was sort of an artistic endeavor. Our hand-built infrastructure was primarily based around physical hardware components, and the way we would wire things up and connect things together was guided by our experience. And one of the challenges that we faced was that really every infrastructure component was something unique, was something special, because every server was built by a different engineer at a different time, and those engineers would have slightly different processes for building servers, and they would have, of course, different backgrounds and different levels of experience. The bottom line was that as engineers, we were just tasked with the responsibility of making something work. And we were sort of craftspeople, stitching things together and making the magic happen. The infrastructure that we built was rarely replaced. We would stick a server in the data center and configure it, and we would fanatically support that server throughout its life cycle, which could be 5 years. And if that server got sick, then we would nurse it back to health. As we are making changes within our organization, our changes were carefully controlled and structured by something like a change advisory board or a CAB. The role of our IT operations staff in the organization was to serve as the gatekeeper for all IT services. And as different constituents within the organization came to us to ask for help or ask for changes to our services, then our main responsibility was to say no and push back on changes, because of course, as the IT organization, we were supposed to be the pinnacle of stability. We were safeguarding the infrastructure of the organization. And our unofficial title was the Office of No. The IT organization itself was oftentimes partitioned into many specialist teams. I still see this sort of partitioning within IT organizations today. You'll see an organization that has network engineers, and then they'll have a storage engineering team, they'll have a database team, and a Windows server team, a Linux server team, and so on. All of these different, very specialized teams that are trying to work together and collaborate to support the infrastructure within the organization. And at the end of the day, the operations team within the IT organization is primarily focused on preventing failures within that infrastructure. Their goal is, and the bottom line is, simply keep the lights on. Now, if you were to try to build a new server within a traditional IT organization, This is a process that literally could take you months, and I've seen this firsthand. Now, there are all kinds of steps involved in provisioning a new server. First of all, you have to make a purchase request and get a purchase order. The vendor has to manufacture the equipment and ship it to you. Once you receive the equipment, then you have to unpack it and do some preliminary building of the server infrastructure itself. You install software, operating system. You do some testing on a local test bench. Maybe at that point you're ready to rack the server inside of a cabinet in the data center. There you need to hook up and provision networking, storage, maybe configure a firewall system, install application servers, install monitoring, install backup software, install security software. Then eventually you get around to migrating data and actually testing the new application. This process literally can take months and months and months. And I've seen this firsthand in organizations. Let's contrast that to a modern IT organization. A modern IT organization is highly mechanized, highly automated. I think of it as a factory of robots. It's a factory where the parts move across the factory production line, and robots are automatically building the components. They're automatically delivering the service. There might be human beings somewhere in the background, but the human beings are just simply modifying the robots. Maybe they're at some point training the robots or writing the code for the automation that the robots perform. But it's a highly automated environment. And the beauty of this is that this automated infrastructure is highly repeatable and highly testable. So as human beings, we are building the machines that build the infrastructure. We're not actually manually building the servers. We're creating the scripts, the automation tasks that build the servers. We eliminate snowflakes within our environment. Snowflakes are those unique infrastructure components, and most every organization has some of these. The snowflake is that server that's sitting over there in a closet somewhere that nobody wants to touch. It was built by a contractor 6 years ago who is long gone, and there's no documentation. Nobody knows how to update it properly. Nobody even knows if it's being backed up properly, and no one dares to turn it off because it's probably providing some sort of critical service to the organization. That's a snowflake, and our goal is to eliminate those snowflakes throughout our organization. As a modern IT organization, we embrace change. We recognize that infrastructure is constantly being replaced. In traditional IT organizations, we would focus on fixing our equipment if it broke. We'd focus on nursing our infrastructure back to health. We look at it very differently in a modern IT organization. We know that our infrastructure, that our topologies is going to be constantly changing, so we embrace that change. And instead of pushing our change requests through a sort of labor-intensive change advisory board that frankly doesn't do a very good job anyways, our infrastructure changes become automated through a service delivery pipeline process, and instead of going through a change advisory board that relies on human-based intervention. And instead of building these physical servers that we literally can take weeks and months to install in our data center environments, today we are building infrastructure in the cloud. We're building servers in the cloud. And it's a process that can literally take a minute or two. So it's literally a minute from, ordering that server, launching that server, to being able to use it and consume it and deliver services from it. It's a dramatic change in terms of the velocity of service delivery. This cloud infrastructure is infrastructure that's available on demand. So we don't have to go out there and buy a bunch of equipment and then wait for it to be provisioned with services and so on. We can provision this equipment at the time that we need it. And so our IT infrastructure capacity can directly align with the demands on our IT organization. And Forbes had an article with a statistic in it a year or so ago, where they said that by the year 2020, they expect approximately 83% of enterprise workloads to be running in the cloud. The reality is that today, at the time that this video was recorded in 2019, we've already passed the tipping point. The majority of enterprise workloads are now running in cloud computing environments, which is a dramatic shift from what existed 5 years ago, even 10 years ago. We've already passed that tipping point, and cloud computing is now the norm.